What is up, mathletes? Welcome back to another episode of Math with Dr. Math. And today we're going to be talking about those partial fraction decompositions. Don't go anywhere. All right, mathletes. So like they say, before you learn how to run, you got to learn how to walk. All right. So what we're going to do is we're going to start off slow because this is an area so many students, they get lost in and they struggle in, and it's because they don't have that foundation. So we're going to make this a multiple part series to make sure that you understand. All right. So the first thing we're going to talk about is setting up the form for a partial fraction decomposition, right? We're going to talk about that form, right? We got to lay down that foundation. So let's start off with example 1 here. And what we're going to look at is when we have these partial fraction decompositions and you're wanting to set up the form, that's the most important step. Everything after that, you've actually seen. So that first part, in my opinion, is the most critical. Let's take a look. All right. So what I'm going to show you today is, with this example, is what happens when you have distinct, right? When you have unique factors. So look at these factors in our denominator. They're different, right? So what happens when they're unique? And not only that, they're linear, right? Look at the exponents. The biggest exponent we see is 1 for each one of those, right? So those are the ones that we're going to pay attention to today. All righty. So what do we do? All right, so let's check this out. So what we're going to do is our goal is to separate this. We're asking this question: what two fractions do I need to add, or can I add, to give me this result right here? So where did this originate from? So how we're essentially going backwards. We're used to adding rational expressions. Now we're tearing that answer apart. We're going backwards, right? So this is where it's coming from, because you're going to see later on how useful that is in going backwards, especially when you talk about integration. But we'll put a pause on that, right, in that calculus class. So here we go. Here's the big idea. Number 1, in your notes, make sure you have in this case, 2 unique factors. And so if the problem they give you is not factored, make sure you write this down. You got to factor it first. And you know I'm your man. Look down below. I have videos to help you factor. So here we have 2 unique factors. So what that's going to tell us is that we're going to have 2 fractions when we break this apart here, right? And we're going to have a fraction for each one of those linear factors. And right now I'm talking about linear factors, right? So the way we set this up, since this is a linear factor, we're going to need to find 2 constants, right? That when we have these constants in these locations, right? If I were to add these up, if I were to add these fractions together, what they're going to give me is they're going to give me this result. So again, I'm going to try to find these values of A and B. So let's actually dive in here so you see what I'm talking about. I know some of you guys, Johnny, you're talking too much. Let's do some math. All right, let's do this. All right, so we went ahead and we broke these apart. All right, so we broke these apart, and look at what we did. Look at what we did here. So we took one of those factors, and the order doesn't matter, and that became one of our denominators. Then we used the other factor, and that became our second denominator. And again, the order doesn't matter. So what we're trying to do, our goal is we're trying to find this value of A and B, such that when you add these 2 fractions, they give you our original statement, rational expression here. All right, so this is our first job, is to set up the scene. All right, so this is part 1. All right, Dr. Math. So now let's look at the big picture here. How do we find those partial fraction decompositions. So we did a big part of the work, right? In my opinion, the most important part is we went ahead and we set up the partial fraction decomposition. We set it up. All right, now let's go in here and let's finish the job. All right, because I don't want to end up like this guy. All right, so how do we finish the job? Well, look at what we have here, folks. And this is what I didn't see. This is what young Dr. Math didn't see back in the day, right? I would try to follow steps, but just think about it. Take a step back. Go ahead, right? This is just a rational equation. So always ask yourself, what are you faced with? What do you have in front of you? Be able to identify what you have. This is a rational equation. And what do you do with rational equations? How do you solve rational equations? Well, we know the answer, right? So let's go ahead and let me copy this down just to give us some more space here. And the reason this is gonna seem like it just takes so long is because of all the writing that you're gonna be doing, all right? So again, just be patient. I think more than anything, we just write a lot, but the actual math itself, it isn't bad. So please don't confuse the two things here. All right, so we have rational expression. So what we're gonna find is the LCD, right? And again, this is nice because our LCD is right in front of our face, right? It's 2x plus 3 and x minus 2. And again, if you have trouble with your rational expressions, we have a video to help you out down below. All right, well, what do we do with that LCD? Well, what we're gonna do with that LCD is we're gonna go ahead and multiply like it's 1999, right? And don't just follow steps, right? Again, we don't wanna just go ahead, Dr. Math is doing it, so I guess I better do it, right? So we wanna understand why. So I always tell folks, is this move helping you? If it's not helping you, then don't do it, right? So why do we multiply everything by that LCD? Well, look what's gonna happen. We're gonna see a bunch of canceling taking place. And then we're not gonna have a rational expression anymore, a rational equation anymore. This is gonna end up looking a lot nicer. So we're on the right path. All right. This next step is crucial, right? So make sure you do this or else none of this is gonna make sense. Like the video and subscribe. And don't forget to tell a friend or 10,000, right? We need to grow, All right, so we're gonna go ahead and we're gonna cancel the 2x plus 3 and we're also gonna cancel the x minus 2. Well, what are we doing on the other side? Same thing. We're gonna cancel the 2x plus 3's. And then in our last fraction here, we have the x minus 2's are canceling. All right, so let's go ahead and write down everything that didn't cancel. So what do we have? We're left with 4x minus 15, and that's gonna be equal to a times x minus 2 plus what's left, the quantity b times 2x plus 3. All right, so now we have one equation, but then people might look at this and start to freak out, right? Because if you look at this, we have three unknowns. We don't know x, we don't know a, and we don't know b. All right, so this is where the fun begins, right? So this is where all the creativity begins. So let's go ahead and let's copy this down, and I want you to copy this down on a new sheet of paper because this is gonna be its own idea, all right? So go ahead, press pause and copy this down onto a brand new sheet of paper. All right, so let's go ahead and distribute this A, and then we're gonna distribute this B value, all right? And again, remember A and B, they represent constants here. So when we see them, right, when I refer to all our constants, we're also talking about our A and B term, all right? Just to help us out here. All right, we have parentheses. What do we usually do with parentheses? Well, we distribute, right? We distribute if we have, right, our terms in front of our parentheses. So we're going to distribute the A, we're going to distribute this B. All right, so let's go ahead and do that. And so we're left with 4x minus 15. And we're on the right hand side, we're left with ax minus 2a. All right, let's distribute that b, and we're gonna be left with 2b, or not to be, x plus 3b. All right, so next what we're gonna do is combine like terms, and we're gonna see why right now. And again, if you have any questions, just raise your hand, right? And I can't see you, so you might want to put it down. All right, so let's combine our like terms. So we're left with 4x minus 15. And on our right hand side, we have ax plus 2bx. And then our constants are 2a plus 3b. I know they're really not constants, but right, for this, the way we're gonna think about this, it's really gonna help us out to think about a and b as our constants, because that's what we're solving for, right? We're solving for a and b, all right? So why do we wanna think in that way? Well, this equation here, for these two sides to be equal, we're gonna do something very creative. Everything that has an x in front of it, we're gonna say that it's equal. So let me do a little rewriting here. All right, so what I want you to note is both of these terms have an x. So usually when they have an x or have something in common, right, we could go ahead and we could factor out that x term. So I'm gonna factor out the x term, and what are we left with in parentheses? Well, we're gonna be left with a plus 2b, or not to be. All right, and why are we doing that? Well, that's gonna help us a lot with our setup, all right? So let's talk about our setup. Everything else here, I'm gonna leave it exactly the same. So if these two sides are equal, right? If these two expressions are equal here, then the coefficient, right, next to the x, this must be equal to 4 over here, because these are both my x terms, so we're gonna equate our x terms. And that just means everything in front of x here, we're gonna set it equal to everything next to our x over here. So we're left with 4, let me do it in blue here, 4 equaling a plus 2b. And there we have one of our equations. Well, if these two are equal, right? If those two are equal, what that means is that these constants over here must be equal, because this is an equation and both sides have to be equal. All right, so we're left with negative 15 is equal to negative 2a plus 3b. Negative 2a plus 3b. And what do you take a look at this? Now we have two equations and two unknowns. And more importantly, right, now I'm going to be able to solve for my a and b value. And that was the whole goal, right? Because in our setup, we're looking for that a and that b value. All right, so now we have two equations and two unknowns, and now you have some options, right, in how to solve this. So I'm going to go ahead and use my addition method. And again, if you need help with that addition method, the link is down below. All right, so I'm going to multiply this top equation here. I'm going to multiply this entire top equation by 2, because I'm planning on canceling those a terms. All right, so we're going to be left with 8 equals 2a plus 4b. All right, notice that bottom equation, we didn't touch it, we didn't need to. So it's going to stay the same. Negative 15 equals negative 2a plus 3b. And according to our elimination method, right, which is another name for the addition method, we go ahead and add our equations here, and those a terms cancel out just like we wanted. All right, so what are we left with? Well, we're left with negative 7 on one hand side, on the left hand side, and on the right hand side, we're left with 7b. Right? So now we could solve for b. Go ahead and divide both sides by 7, and you're left with b equals negative 1. So there's our b term. our B value, excuse me. All right, now I could plug this into any of those two equations that we had to begin with, and now I could solve for A. So let me go ahead and plug it into my top equation right here. So I'm going to use 4 equals A plus 2 times B, but now we know what B is, right? We just found B is -1. So we have 4 equals A plus, well, I'll just put -2, right? And now we could easily solve for A by adding 2 to both sides. So you get A equaling 6. So now we have the value of A and we have the value of B. So let's go ahead and let's plug these in. All right, folks, so let's put everything together here. We know what A and B are. And remember, our goal was to take this original rational function and to break it up into a rational expression with 2 smaller pieces because we're going to want to do something with this a little bit later, right? And so this is the whole idea. So this is our form that we came up with, and we wanted to find the values of A and B to make this equation true, and we just did. So if we were to break this up, this is the same exact thing as 6 over 2x plus 3 plus the other fraction of -1 over x minus 2. And if you wanted, of course, you could bring that -1 here, or sorry, that negative sign, and this could end up being 6 over 2x plus 3 minus 1 over x minus 2. And so now we've completed our mission, which was to break up this rational expression into 2 smaller pieces, right? Because again, we're going to be doing something shortly with these 2 pieces. All right, folks, so that was a long one, right? Just follow those easy 2074 steps and you're done. All right, so again, be patient with yourself, and this only works when we're talking about linear factors in our denominator. And notice they did not repeat themselves. So next, what we're going to talk about is what happens when they do repeat themselves. So stay tuned. We'll see you in the next video. Peace.